So the transition table could be really easy. All we would do is turn A into 0, 0, 0. Whenever A appears, we put 0, 0, 0 by it. We chose 3 zeros because there's 1, 2, 3, 4, 5, 6, 7, 8. So we need 2 to the third power. We need 3 flip-flops, and each one of these represents the internal flip-flop, Q1, Q2, and Q3. And we could say B001, 001, 001, 001, 001, C010, etc. The trouble with this simple method is that it's fast from a design point of view, but our resulting circuit's going to be slower than if we put a little bit more thought into it. So the little bit more thought starts off with these 3 rules. And the first rule basically says, if the states are almost equal, but their outputs differ, put them next to each other. So let's look. What do we have? State A has an A and a B. All right, do we see someplace else with an A and a B? No. State B has a B and a C. Hey, G has a B and a C. But the only reason they're not combined together is their outputs are different. So B has the same state right here and the same state right here. Same vertical states for the same input, right? So this B and this B, this C and this C. Well, these C's are underneath the input of a 1. So we should write down here BG twice. Twice because both of these matched up. I mean, that's a big match. Now, where's another one? Here's a D and a D. That's between C and F. So between C and state C, present state C and present state F, they both share this next state D if we have an input of 0. So we're going to write down here C and F. But they only do that when the input's a 0. They don't do it when the input's a 1. All right, what's another one? F and A. Okay, D and H. Wow, D and H share 2 of them, right? They would be equivalent states if they didn't differ in their output. So we're going to say D and H twice. D and H twice. D, H, D, H. So in more complicated problems, we could have 2 inputs, x1 and x2. 0, 0, 0, 1, 1, 0, and 1, 1. These 2 would be adjacent. These 2 would be adjacent. These 2 would be adjacent. But here we just have a pair, so we know these 2 are adjacent. So what we're doing is we're looking for how many occurrences of AB do we have in this table, in this column right here. So we've got, let's see, let's change pen colors here. So we've got how many times we have AB? AB, just AB is once. How many times do we have BC? 1, 2, 3. So we have BC, BC, BC. Okay, how many times do we have DE? 1. That's it. We just have DE once. How about FG? We have it twice, right? FG, FG. CB we've already covered. DH. HD. DH. So we have DH just once. And then BC we've covered and FG we've covered. Okay, and then the final rule is to try to match up states with the same output. So A, B, C, and H all have 0, 0s as output. D and F have a 1, 0, and then E and G have a 0, 1. So this is the priority system for creating our state assignment. what we have is our 3 flip-flops, Q1, and then we form something that looks like a Carnot map. And these are Q2 and Q3. So we look at our first rules right here. We need BG and DH next to each other. So what are we going to do? It doesn't really matter. B, G, and then D, H next to each other. All right, and the next most important things are C and F and A and E. Down here we need B and C next to each other 3 times. So I'm going to put a C right here. That guarantees that one. Then I'm going to go up here to the CF, and I can put an F right here under the H or under the G. Looks like I need the F underneath the G. All right, so I'm going to put a CF underneath the G to satisfy that one. All right. And now I need an AE. Where do I put the A? Well, I need AB. I'm not going to be able to satisfy that one. There's no more place to put. I've got H next to B. What if I redraw this? Let's try it again. Okay, let's just start off with BG. And let's put our C and our F down here. Now, do B and H need to be next to each other? I don't see it here at all, except maybe in this one. That's down here in Rule 3. So let's go back up here. B and C I've covered. F and G I've covered. Now let's see this. D and H, I need it here. Yeah, that's okay. So A and E. What else does B need to be next to? Let's just ask the question that way. It needs to be next to A. That's it. So let's make sure that B is next to A. That's the only place we can put something next to B. Now A needs to be next to E. Now I can put E here, or I could put E down below. What does E need to be next to? It needs to be next to D. All right. E needs to be next to D. Where's D? I don't have a D in here yet. All right. If I put an E right here, I satisfied that one. Now I need E next to what? D. So if I put a D here, then that means to keep this priority high, H has to be here. Okay, so this row's happy. All right, we've done this row. Now let's check. A and B, yes, that's happy. B and C's happy. D and E. D and E are next to each other right here, right? Yes, D and E are next to each other right here, so that's happy. F and G are next to each other right here, so that's happy. D and H wrap around, yes, that's happy. Okay, A, B, C, and H, wow, that was by accident. D and F, yes, and E and G. So this looks like the solution. So let's draw it out big and clear. All right, let's scroll down and see if this is what the book came up with. A, B, C, H. Wow, F, D, G, E. Well, let's check their rules out. BG, yes, it's right here. CF, yes. DH, yes. AE, yes. AB, yes. BC 3 times, yes. DE, D wraps around to E, yes. FG, yes. DH, yes. ABCH, DF, yeah. So there, it looks like there's at least, there's an alternative right there. So there's 2 ways to do it. So the next step is to draw the transition table. Here we can see that A is 3 zeros, so it's going to be 0, 0, 0, 0, 0, 0. B is 0, 0, 1, 0, 0, 1, 0, 0, 1. C is 0, 1, 1. 0, 1, 1. So C is 0, 1, 1. 0, 1, 1. Where's B? 0, 0, 1. 0, 0, 1. D is 1, 1, 0. 1, 1, 0. 1, 1, 0. 1, 1, 0. Oh, there's a C. 0, 1, 1. There's a B. 0, 0, 1. You can get the pattern. It's not too complicated. E is 1, 0, 0. So E is 1, 0, 0. And we can scroll down and see this typed in. Yeah. Okay. The next step after the transition table is the excitation table. So I'd like to go through that process with you, finish this problem off. So we have as inputs, we have Q1, Q2, Q3, and X. As outputs that we have to compute, we have Q1 plus, Q2 plus, and Q3 plus, and Z. Now obviously we're going to be using D flip-flops because we're going straight to the excitation table. So you need to think of these Q's as D1, D2, D3, X, and these outputs as D1 plus, D2 plus, and D3 plus Z. Now we're going to do just the Carnot map for this one. So let's call it Q2. And here's what the Carnot map looks like. And we're going to just follow this truth table as much as we can. So Q1, Q2 are our inputs. Q1, Q2, and they're going to be 0, 0, 0, 1, 1, 1, 1, 0. These are our other two inputs, Q3 and X, Q3 and X. Now, since we're doing Q2, that's this middle column right here. So I'm going to block out the other two columns so that we can zoom in. Here's the problem. These are not counting anymore. So these columns are not 0, 1, 2, 3, 4, 5, 6, 7. We can't go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 real slowly. So I'm going to do them in pairs using different colors. So that 0 right there is 0, 0, 0, 0. This 0 right here is 0, 0, 0, 1. This is 0, 0, 1, 0. 0, 0, 1, 0. And this one right here is 0, 0, 1, 1. 0, 0, 1, 1. That is 0, 1, 1, 0. 0, 1, 1, 0. This is 0, 1, 1, 1. 0, 1, 1, 1. This is 1, 1, 0, 0. 1, 1, 0, 0. So you can see we're not following any pattern over here. That 0 is 1, 1, 0, 1. 1, 1, 0, 1. That one is 1, 1, 1, 0, 0, 0. 1, 0, 0, 0. There's that 1. And this 0 right here is 1, 0, 0, 1. 1, 0, 0, 1. So that's a 0. So this 1 right here is 1, 1, 1, 0. 1, 1, 1, 0. Is that 1? And this 1 right here is 1, 1, 1, 1. Okay, that 0 is 1, 0, 1, 0. 1, 0, 1, 0 is this 0. And this 1 is 1, 0, 1, 1. 1, 0, 1, 1. And finally, this 1 right here is 0, 1, 0, 0. 0, 1, 0, 0 is that 1. And this 0 right here is 0, 1, 0, 1. 0, 1, 0, 1 is that 0. Right, so this is Q plus, our next Q. And we can compare it to the table down here. Yeah, they're the same. So this is the equation for it. 1, 2, 3, 4 mini terms. Yeah. And we can see the equations for the rest of the circuit here. And we can build this inside a Logisim. That's what I want to do next, because that's not straightforward anymore. So to do this in Logisim, I'm going to count these rows. This is row 0, this is row 5, and this is row 2. So I fired up Logisim. I'm going to do a combinatory analysis. So my inputs are going to be, my outputs are going to be, okay, so here's my table. All right, so this is my first row, 0, right here, 0. So I'm going to have 0, 0, 0, 0, 0, 0, and 0. So it's going to be 0, 0, 1, 0, 0, 0, 0, 0, 1, 0. So each of these rows right here, this 0 represents 2 rows on the truth table. That 1 represents 2 rows in the truth table. I'm just going to go down the truth table. So this is row 1, and it's 0, 0, 0, 1, 0. 0, 0, 1, 0. And then the alternate row is 0, 1, 1, 0. 0, 1, 1, 0. Now I'm going to go to the next 2 rows, which are down here, 2. So 1, 1, 1, 0. 1, 1, 1, 0. And then 1, 0, 1, 0. 1, 0, 1, 0. And then the last row is going to be 1, 1, 0, 1. 1, 1, 0, 1. And then 0, 1, 0, 0. 0, 1, 0, 0. Now I'm going to say build the circuit in main and say OK. Replace the main circuit. Yes. So the first thing we want to do is rename this truth table, something like that, so that the circuit has this name truth table on it. This way, if we made a mistake in our truth table that generated this, we're not stuck with rebuilding the circuit over and over and over again. Then what we want to do is go to Project and add a new circuit and call it main, the new main, and put in it this guy, Q1, Q2, Q3, and X, and our 4 outputs, D1, D2, D3, and Z. Now what we want to do is attach our flip-flops. And then we're going to have our 4 inputs. Well, what are our inputs? Well, we really only have one input. That's our X. And our inputs, really, this is our Q, our first flip-flop. So it goes right here. This is our second flip-flop. It goes right here. And this is our third flip-flop. This is the feedback, right? This is the memory on top of memory. There we go. So now we're ready to test it. So let's say everything's looking good right now. We're at this state right here, 0, 0, 0, 0, 0, 0. Our inputs is 0, so we're sitting right here. And if I hit the clock, nothing should happen. I should stay here and output is 0. So let's hit the clock. Nothing happens and I stay there. So let's switch to an input of a 1, get off this thing. So we moved over to here. And we can see that D's are 0, 0, 1. So we can look at the input, 0, 0, and a 1. So when I hit this clock, I get that 0, 1 moves in. This is mealy. So that 0 is that 0 right there. Right, because we're sitting here at a 0, 0, 1, 0, 0, 1, Our input's a 1, so I'm in this 1 column. Yeah, so I've got a 0, 1, 1 set up, 0, 1, 1 set up coming in on the next clock tick, and I'm outputting a 0 right now. And we want to head towards one of these 1s. So how do we get there? 0, 1, 1 is going to get us here. How do we get to there? Well, let's just force our way to this state right here. So I'm going to force my way there by forcing these flip-flops to a 1. So I'm going to click a 1 and a 1.